go ahead and get started. Last breakout session of the afternoon. So, good afternoon. I'm Matt Gruen. I lead the SE organization at Hedvig. And as you heard from our CEO Avinash Lakshman this morning, we have recently introduced the concept of a universal data plane. So I'm going to talk a little about that. I'm going to talk a little about how Hedvig implements that, and then we encourage you, in about 25 minutes, it's hard to cover everything, so love to follow up with you and talk to you more about that. And certainly stop me along the way if you have questions. If we get too far off, I'll be watching for a time and keep us moving. So, Avinash spoke a little about the universal data plane, but let's just think for a minute. Imagine you're an IT guy or gal at virtually any company today. There's lots of different pressures. There's lots of different requests coming into you. It could be in a new application. It could be in the expansion of an existing one. It could be a business continuance initiative. It could be digitizing. We had a few of the speakers this morning talked about that, how the world is digitizing today. If you're in IT at Oral-B right now, does everybody know what Oral-B does, by the way, as a company? They do toothbrushes, right? If you're in IT at Oral-B right now, you've got to handle the fact that they are now selling a $100 toothbrush that has built-in sensors that through Bluetooth, through an app on your smartphone, go back to headquarters and tell you this is how tell them this is how you're brushing, and then you get some feedback. I don't think they call you mother, but this is what's going on right now in terms of Internet of Things. So you're having to process that. Maybe you're having to back up. There are lots of things going on. There's also, by the way, this little thing called budget. And you're always being asked to do the proverbial more with less. So how do you achieve that? How do you meet those requirements in a cost-effective manner? And that's what we aim to do at Hedvig. So as Avinash explained this morning in a nutshell, our vision of the universal data plane is one where there are multiple types of workloads. They could be in a traditional Linux or Windows environment. They may be in a virtualized world. It could be Docker. There could be swarms of Docker. There could be any number of platforms. They could have multiple tiers. There could be this toothbrush data, which could be important to you at Oral-B, but it's probably not as important as perhaps the ERP data. Right? And it's probably more important than maybe some test dev kinds of things. And then maybe there's the initiative of clouds. And I think it was Diane from Intel was talking about, look, the average company today has 6 clouds they're working with. Some of those private clouds, some of those public. Perhaps they're hybrid, where some are doing that in the context of running both in their data center and also out in the cloud. So those are all options, those are all things that companies are trying to do. We're trying to provide a single platform that, we talk about programmable, right? So easily manipulatable, configurable, something in a DevOps context that would make sense. It spans workloads, clouds, and tiers. It spans all 3 dimensions of that cube. It allows for data portability. So data that today is perhaps in a private cloud could move up to a public cloud. And then maybe over time, by the way, maybe that public cloud, pick one, Amazon, AWS, maybe that's not working out for you some way, or maybe Google is really trying to get your business and they've offered you a good deal. You'd like to move that data to Google. Well, guess what happens when you take the data out of Amazon? The cash register really starts turning, right? That's a typical cloud paradigm, is the egress from the cloud is very expensive. So wouldn't it be nice to be able to do things without incurring those charges? and at the same time we provide both, or be able to provide both data locality and to also be able to assure that there's some diversification, that you have the resilience you need to ensure continuous business operations, right? So you want to be able to provide availability guarantees. So this, in a nutshell, is what we think of when we think of the universal data plane. We think it should be something, again, that's that single platform that addresses the different layers. And I'll spend just a little time on this. Again, Avinash was not able to. But that data today may look like object, file, or block. It may have different characteristics to it. It needs to be able to back up. You need some kind of replication around business continuity. And then there's the notion of high availability and DR. We have, at the application layer, how are you implementing those applications? Again, they could be VMs, they could be containers. Had a call with a customer today, actually, where they're talking Photon, which, if you didn't know, is VMware's take on it. So I guess that's containers on VMs. So we may have to change the slide or overlap it somehow, as well as in clouds. And then you have an orchestration layer, right? So is it a hypervisor itself that's orchestrating the management of those resources, the movement, or is it one of the newer versions? And you know, we heard from Bryce today with OpenStack, but whatever that is, needs to be able to accommodate that. And that's something that we do with Hedvig. So can we, as the business policy, because by the way, we don't do this because it's cool, we do it because the business has needs and we're providing technology that addresses that business. So can we meet the business needs by spinning up those workloads dynamically? Can we make sure, again, it's protected in both potentially a public and a private space? And as I gave an example a minute ago, avoiding the cloud lock-in. So again, once you get data into the cloud, some of the speakers talked on stage today about the fact that can get to be expensive at scale. The cloud is great for its flexibility. It's near instantaneous, not only, I started to say availability, but just the pervasiveness. So if I want to try something, I can spin it up in the cloud and get it going, boy, just like that. And that's a great thing. But then I got it going, and then it starts going and going and going, and all of a sudden the number of compute instances, the amount of data, results in a big charge. So can we work with that and eventually have some flexibility around it? This is the main set of capabilities. These are the design goals, as it were, for Hedvig. So we want something that's scale out. So Avinash, our founder, he was one of the folks that invented Amazon Dynamo, which is the underlying database system for the Amazon checkout, right? So the shopping cart at Amazon. He then moved to Facebook and developed Cassandra. So he's the developer of Cassandra. They eventually put that, that's now in the Apache project. But he did that. So he understands systems at scale. He understands what it takes to, as you build a functionality or implement a functionality, how do you do that in a way that'll still work at thousands or millions like it does at tens or hundreds? We also have a platform where we inherently understand how data is distributed, how the components are distributed. So again, this is software-defined storage. We're going to have servers, say a QuantaGrid V51PH. Oh, you didn't get paid for that. But we're going to have servers where we run the storage, right? And we can be aware of where those are by data center, by rack in a data center, and make sure data is spread out according to policy you want. And it's also done very flexibly. We have not only a GUI, of course, but APIs, CLIs. The APIs are REST-based, so full automation and integration that's available to us for orchestrating requirements. We also integrate with the orchestration layers that we saw in the previous slide, like an OpenStack. We also, it's important, we think, that your data platform is application aware. And so that can mean a couple things, right? That can mean specific integrations. Again, if it's VMware related, we have a vSphere plugin. If you're going to operate in a Docker world, we can integrate, we can actually provision Hedvig storage through Docker data centers. So we have that kind of availability. But it also means that by application, you can specify specific characteristics of your storage. So there's very little that's kind of just sat there or implemented in Hedvig that's not customizable. One particular item that comes to mind is thin provisioning. We do thin provisioning across all our platform. But as Avinash mentioned earlier, whether you want to compress or something, you know what? If it's a lot of internet sensor data that's telemetry oriented, it may not be too compressible. It may or may not be dedupable. So we allow you to specify things like that as needed to be optimal for your application. And then finally, is it simplistic enough operationally to even run on a smartphone or tablet? And we do have that. We can show you eventually, not today, but we can show you the GUI in that kind of context as well. By the way, I've been in the storage business a little bit, and I've always had customers, well, not always, I guess, since smartphones were a thing, say, hey, can I do that on my Android? Can I do that on my iPhone? And I've always said, hey, yeah, maybe. Well, now I've got a product that can do it, and I'm still not convinced how many customers really want to provision on this thing where, we all make typos or we actually, oh, did I double tap? I didn't mean to, So are you really going to do your storage that way? But you can. So here's some of the characteristics. So first, we are hardware agnostic. Again, forgive us please to the QCT people, but we'll run on any 64-bit x86 platform. Depending on the amount of storage you put on each storage node, we're gonna provide, or we're gonna ask that you have some ratio of memory and some amount of flash as a front end to help accelerate some of the operations. But any 64-bit x86, we're also designed for ARM. Quite frankly, we thought ARM would be a thing by now, and it's not. At least not in the customer base we see, but when it comes, we'll be there. As I mentioned earlier, we're multi-data center and cloud aware at our core. So as you add nodes into a Hedvig system, you can tell it which data centers it's in, and then as you provision storage, you can say which data centers you'd like that particular virtual disk or logical volume to be in. We can do things in both a hyperscale and a hyperconverged mode. This is hyperconverged day, right? So it is possible to run Hedvig in a hyperconverged setting, but also at scale, you may want to separate components of our architecture, and I'll show you that on our next slide, and scale those independently. So either approach, we have that flexibility. The applications themselves can run in any hypervisor, any container environment, any OS. Again, we're going to present block as iSCSI, file as NFS, or object as S3 or Swift. So to the extent that you have a container OS hypervisor that understands those protocols, you can access Hedvig storage. All the things that we can do, we do at a what we call virtual disk level, or vDisk, or logical volume level. So that's even finer granularity than the application, right? You could have an application where the core data, you want to make sure it's replicated around the world, and other piece parts of it maybe aren't so important and don't have that same level of replication. We can do things like dedupe, compress, we can do snapshots and clones, and again, all that's available per virtual disk. So here's a technical slide then to tell you how we do things. So at a starting point, we would take these 64-bit x86 servers and we'd layer our software on top of that and turn those into storage nodes down at the storage tier. In this particular example, we suggested they're in data center 1, 2, and maybe public cloud 1, because a cloud to us looks just like another data center. I'm going to stand right here because the air conditioning just came on. And then up there is an application tier. And so we have the ability then to present these virtual disks up to the application tier through a proxy service. And that proxy service could run as a virtual machine in a hypervisor. It could run as a Docker container. It could run on bare metal. But the point is that as we're doing this, right, we're providing this service then up to these applications. These applications only know about the proxy service. They only know they're talking NFS or iSCSI or accessing objects through this proxy. They're blissfully unaware of all this down here. That's something that's not important to the individual application. As we have more hosts that scale out, right, and there's more need for host IOPS, we scale out the number of proxies. As we have a need for more storage or more back-end IOPS, we scale out the number of server nodes. And that can be done in a hyperscale environment independently. And so again, we get the most efficient utilization possible. What this example is showing is that for each of these 3 volumes then, we would have things set like, maybe one of these is block, deduped, it's got 3 copies, replication factor of 3, it's aware of the data center, so 1 copy in each of these 3, and we might have caching up here so that we accelerate the reads. So that's something, again, you dial in per virtual disk. The storage proxies themselves then provide that access to the individual applications. And here then on the right is where we make sure those 3 copies are made across to the data center. We have some intelligence built into our platform so that we'll acknowledge that write when a quorum of writes have completed. So we have synchronous across, in this case, 2 out of the 3, and we'll acknowledge. And eventually, we write the 3rd, asynchronous to these, asynchronous to that process. But when we read, we also read with the quorum, so we're ensured we always have the right data, regardless of the failure scenarios. And the way we get to hyperconvergence then is we say, hey, let's make all of this a hypervisor. And now in one physical platform, we have all that functionality. And to Mike Yang's part, maybe in a hyperscaler, one of the very big companies, world of hyperscale, doing it in this more compact platform allows accessibility to more folks. Yeah.
So are you saying that Hedvig will maintain synchronization between all the replicators?
Yes, it'll maintain synchronization, and for instance, one of the things it does, it's aware of the latency between those, and it will actually optimize over time on the reads to know where is the more likely place that it'll get a quicker read back, but it's very aware of that.
So even if there are multiple writers, it will maintain the synchronization?
It will maintain the synchronization. These are iSCSI and NFS, so we need to talk about what multiple writers mean, because there's still some semantics within iSCSI and NFS. So there are places where we could have it, but more often it's going to be an individual writer at a time. It could be per volume. So, every volume has 1 writer. If you want 1 writer or multiple writers with 1 volume, let's talk about that offline. Let me just finish up and give some props to QCT. We worked with them on a Docker reference architecture. We presented this at DockerCon. I think I was in this very room getting it ready back in the day. But we have this available on the website. We have demos out there as well. And as Al and I said, the QuantaGrid, the 1U system with 12 3.5-inch drives, 4 SSDs, has just a great blend of storage and processing power to be ideal for the Hedvig architecture. And so there is the QuantaGrid, and this gives you an example of what we spec'd out in the Docker reference. And of course, nowadays, I was told just yesterday now, QCT offers a 12 terabyte drive. We'll have to work through what that means and what may change here. But that's just one example of something where we've successfully implemented. So here's a couple of use cases, and I know I'm running out of time, but here's virtualization. And I guess one of the points I wanted to make, very busy slide, but these are virtualized environments, also running in a couple clouds. By the way, notice this cloud has some proxies and some storage node. This cloud has proxies, it has no storage node, so it's accessing everything remotely. But all of this is one Hedvig cluster, including the proxies. So when you manage Hedvig, that's what you get to see. And then finally, backup to disk is another popular use case, and that's something we can do as well. So listen, I'm out of time. I really appreciate your attention. If you'd like to ask some questions, please come up. I'll be here for a minute or two. Thank you very much.